Hello everybody, thanks for stopping by my shop again. Welcome your visit, and I think I have a pretty interesting video for you today. It's a variety of items. But let's start off with a little fun here. It's been burning my brain. So as you probably all watched Tom Lipton, of course, Ox Tool, and I was watching one of his videos the other day, and he made a comment during the video. Very simple comment. And I've had an earworm ever since then. It's probably on 3 or 4 days now. You guys probably heard the comment. Very simple one. And he was going over a couple items and he says, da-da-da, da-da-da, and Bob's your uncle. Well, that damn statement, Bob's your uncle, all night was in my head, the next day, all day. I'm almost done with it. Hopefully talking about it here doesn't burn on further. So anyway, Bob's your uncle. So let's move on to some more information. I want to promote a website, not a website, but another YouTube creator. Here's his channel name. Robin is his name. I've actually been subscribed to him for some time, and I don't know, I just really hadn't keyed in on watching, and he's just been doing some great videos. The quality of his videos are very, very good, and he's been doing a lot of grinder demonstration and setup, some very precision work. Pay Robin a visit. I think you'll really enjoy seeing his channel. So let's move on to the next item of discussion here. Of course, like I said, I watch YouTube channels, and happened to watch Mr. Pete the other day. And he was showing some quick change tooling that he either purchased or got given to him. And I've got to make a little small pallet for a buddy, and I thought about the tooling I had, so let's flip to a video and show you the tooling. It's actually right here in the mill right now, and we'll come back and talk about it. Well, I'm going to make a pallet for a buddy, and I saw a Tublicane, Mr. Pete, use his quick change tooling the other day, and I do have a tapping head, but I thought I'd show you this. What do you think? Pretty quick. So that tooling is it's a Tapmatic Jahrl, Jahrl, and I can't remember when I had actually purchased it or picked it up in a tooling buy. I have 2 of the male units, and these units use like a rubber flex collet is what holds the tooling. And I have two sizes of collets. They're metric, One is 2.5 to 4.5, and the second one is 4.5 to 6.5. Well, of the smaller collets, I do have 3 of them, and that's hence why I can use two matching sizes here to drill and tap with. I've looked, I can't seem to find any more. I would buy them if I could find them. Pretty cool tool that you can change tooling with the mill operating, and I was at, what was I at on speed? That was at 660 on the speed that you saw in that video. Okay, so let's move on from there. I'm going to show you just a quick photo of a hammer rack I did in my wood shop, and then we're going to take a run over to Carl's. Carl, if you remember, we had showed some video on his Rivet lathe problem with it, and I'm going to show you the video that we took the other day and interject, I think it's Screwy Tuesday 57 for a little reference video also there. So let's look at a hammer rack and then off to Carl's. We're going handheld here for the hammer rack. This was a copy from one of my buddies, and you can see I got an assortment, and it's real simple to pull a hammer out and put a hammer back in. So I borrowed the idea from him, and hopefully you'll borrow the idea from me.
Well guys, those of you who like to watch Chuck's videos, I'm back showing what's going on with the Rivet lathe. Just a reminder, when I left off, I had the turret sitting right here with an indicator, and it looked like the turret slide, as it advances the tool into the work, was going downhill. This is a Rivet 918S turret lathe, sometimes called a second operation lathe. Various tools may be placed in the holes in the turret, and of course if you guys know a little bit about turret lathes, when all things are put together and working, this presents a different tool to the work that's held in the spindle of the lathe. Okay, this will be quick. I'm just going to show that the turret slide is not well aligned with the bed, and so let's see if we can get this thing moving. There we go. So in the span of 2 3/4 inches, the dial indicator moves about 1.5 thousandths. I worked on it for some time and wasn't getting anywhere, and finally decided to take it off and put on the surface plate and check and see if I was getting the same readings. On the surface plate it said, well no, it says that turret slide, as the slide moves this way, is running perfectly level with the bottom surface of the turret against here. The problem was not in the turret, and as a couple of you have pointed out in comments on my previous video, the bed was worn enough, was sway back like this. The turret was pointing downhill, but it was reading against the section that was going uphill. So it looked like the turret slide was aimed downhill. That meant, as at least 2 or 3 of you said, I needed to grind the bed. That has been done. Process of grinding, I had to take the headstock off, and so the next step is to check the headstock. Well, as it turns out, quite interestingly, there was more error in the headstock than there was in the tailstock. And I have set this up a 234 block, Noga indicator, 1/2 thousandths indicator, to check the alignment of the spindle. Now, this is done with I've got a 4-jaw chuck carrying this a spindle alignment bar, and this is running almost perfectly true here, and just a couple of tenths run out there. This means that this bar is almost exactly aligned with the axis of the spindle itself. Has no reference to the bed, because the indicator here is reading 0, and out here it's reading almost -5. In fact, it is reading -5, but the run out is the same. So that implies that this bar and the spindle is going downhill. I'll show you this again. The process of aligning this bar is first use the 4-jaw chuck. Let me get a little closer. Use the 4-jaw chuck to align to center the bar here with the axis of the spindle, and then you go out here and use these screws to tilt this bar in as close to parallel as you can get. And so then you go back here. Adjusting these screws will change the alignment here, and so you have to come back and use the 4-jaw chuck to realign that. Go back out here and using the screws again to align the end of the test bar. The key to this is these two plates have a ball bearing centered on the plates, and that separates the headstock bearing from the test bar. I mean the headstock plate from the test bar plate, and the two are then connected by these 4 screws. So this operates kind of like a face type 4-jaw chuck. The principle is exactly the same. So now that we know that the spindle is aligned this way with the axis of the test bar is aligned with the spindle, and we know that the spindle is aimed downhill, we'll go off camera for just a second. I'm going to reset the indicator, and I'm going to check the alignment in this direction. So we know in this direction is downhill. I want to check the alignment in this direction. Okay, I've reset the indicator to check the alignment in this direction. We're reading 0 here, and we are going downhill about 2.5 thousandths to here. That means that the spindle is misaligned this way by about 2.5 to 3 thousandths in 10 inches. The next step will be I'm going to lift the spindle off, turn it upside down, and I want to read the underside. Now, before I do that, I want to show you this. The grinder guy would very kindly ground the bed so that the top surface is just a little bit low. That means that I have to take material off of the bevels in the headstock in order to drop it. It has to come down, and in the process of coming down, the backside has to come down faster, and see, it's tipping this way. I also have to cant the bevels in here this way. So I want to show you two little things. The first is this little pack of thickness gauges. I took 2 standard thickness gauges, cut them apart, put them in these coin envelopes, and real quickly, any size thickness gauge, very quickly get it out. It's easier to use these than the ones where they have all of them in one and it's real heavy and is a problem. So this has been a marvelous tool. I've used it a lot over the years, and I certainly recommend it to everybody. Then I also want to show you this little sled that I made. Again, 2-3-4 block. 2 reference surfaces. These are ground mild steel, and then there are 2 dowel pins that are secured with just little tiny dabs of hot melt glue. So these are my reference surfaces, 1, 2, 3, and they form a sled that will follow this very accurately. Okay, we'll take another quick break. The next thing I want to show you will be the rigging for getting the headstock off, and I'll be back in just a bit. Okay, here we go. Whoops, wrong handle. You'll probably recognize my version of one of the engine lifting adjustment gadgets. I saw those and I thought, well, I could make a better one than the sheet metal things that you commonly found. So I had a lead screw and a nut and some bar stock and some channel, and went at it. Handy tool. Okay, we'll be right back in a second. Okay, the headstock is off, turned upside down, and I want to look at the bevels. Well, I have an idea that quite possibly they are not the same width. So I have this gauge set up. Again, it's very similar to the other one, a 1-2-3 block. 5/8 dowel, a couple of dots of hot melt, mag base, and my indicator. And so basically I'm going to set it on here like this, hold it fairly carefully on the back, and rotate this down. And that says 5/10 above the 0 reading in the middle. 5/1000ths. That's a 0.5 less. So that suggests that quite possibly that one is not straight. Put over here, starting again at the left. 5.
Ooh.
3.5. 2.5. That suggests that this rear set of bevels is not quite the same as the front set. Let's do this all over again. That's minus 2.5. It's about 3. 5. That's suggesting that this back one diverges this way. 6. It was 5 before, so we're slightly inconsistent. 4.5. 5. Pretty much the same. So at this point, with the preliminary reading, I think there's an error in these. However, if this is, let's see, gotta reach which way this is going. Yeah, it says that this is converging this way. I'm sorry, I used the word diverging before, but this is closer, which would put it higher this and tilt it down this way. So both tests indicate so far the same thing, that the headstock spindle is going downhill, and it's because these bevels are incorrectly aligned. We're going to close for a second. I'm going to make a couple of changes. Be right back. I cleaned the bluing off of this because I wanted to show you something that was apparent when I turned it upside down before I put the bluing on initially, and that is the surface finish on these is strange. It is obviously not a milled surface. Does not look like a scraped surface. Clearly not a ground surface. I don't know how this surface was produced. You can see the high spots now that it's rubbed up and down on the. I did this with a stone. You can see the high spots. You can see the low spots, and these high spots tend to be long and pretty much aligned. So I don't really know what made these kind of markings, and so that's one of the things, is that in the process I'll clean this up. This did not mark at all. When I turned it upside down, I expected to see these high spots would be, in some places, would be rubbed away. The marking would be rubbed away. They were not. And so Chuck got busy with the flashlight and an examination of the bed, and we're going to show you that next. We want to show you what actually happened, or another thing that happened. Apologize for the problems with the lighting on this. We experimented quite a bit trying to show it. These very well ground surfaces are highly reflective, and getting a hot spot out of the picture was kind of tough. What we found was that when the grinder did this surface right here, he didn't lap the edge of the wheel over the end of the bevel. And there's actually a little tiny ridge right here. And Chuck found this by looking at the marking down here. We expected to see some blue rubbed off on this surface somewhere, and we couldn't see it outside of this little area here, and then on the back side there's another little area. And that was primarily places where I had put a little too much blue. I didn't want to put it out thin. I put it on fairly thick, and so I just kind of rubbed. So Chuck got a flashlight, was looking at it very carefully, and he says, well, I see just a tiny line of blue right there. And we began investigating it with our fingernails, and he says, well, there's a ridge there. And so the final test was the standard. You put a straight edge on, and you look at a light back there, and lo and behold, there is a great big wedge of light showing up. So we know there's a problem with the grind, and there's no point in going any farther with this. Going back to the shop and have them take care of that. And that's all for tonight. Thank you very much, guys.
Well, I hope you enjoyed the video over at Carl's. A little bit of bad news there at the end. We will keep you posted. He has not yet got a hold of the grinder the last time I had talked to him. And as soon as we get more update on it, and of course the bed's going to be reground, and then we'll be back over there going through it. In closing, my good buddy Howie, who's not in this video, who's not bugging me right now, I think he's over in the wood shop thinking I'm going to walk back over there. Well, he went on vacation, and so we'll finish up this video with a little video of Howie went to the beach with my son last weekend, and he spent the weekend over in Santa Cruz. Hope you enjoy it, and like always, we'll see you next Screwy Tuesday. And I always appreciate you stopping by. Take care.